All right. This is a quick sort of practical use of row-level security and how it could be implemented. I'm going to go through a permutation idea, so this is a form of implementing row-level security in transactional SQL. So the first thing, obviously, we need to have is some data. So I created a billion rows or 100 million rows of random sequential data, strange as that might seem. So I've got a random global unique ID and a sequential row ID, right? Out of this, I then created a set of random permutations. And let me walk through the oops, sorry, wrong button. This one. So let's walk through the scenario. So I took the sequence. I wanted a random 20 random 20 modulations of a specific, well, of a static random ID, if you want to call that, right? And then on top of that, I wanted to create some real randomness. And the reason for this is because these are these columns that have been created, these 4 columns of randomness, have been created to simulate foreign keys or surrogate keys of foreign keys, right? And the idea is that you might have security based on a clustered collective, right? And what I mean by a clustered collective is you have a sequence of numbers that cluster together. So in other words, think of it that you have 100 million transactions, right? And it's a whatever it is, sales organization, right? So let's say it's product by shop, right? So you have a shop that will sell many different products, but the same product will also be sold in many different shops. So that at some point, you will get commonalities between those two fields. Like they will occur, out of your 100 million sales transactions, you're likely to have sold the same product at the same shop, right? Which means that your you sort of collapse the filter, and it becomes more common, right? So you'll get clusters of the combinations that will be associated with many transactions. Okay, so that's not rocket science, and that's pretty much how row-level security has been implemented everywhere in the analytical world forever, right? With the slight difference of Tableau as a data engine, but we're not going to go into that. That's semantics. So, what I've done for this exercise is that I took my 100 million rows and I generated a data set of 1 million random, because a million transactions was more than enough to illustrate that out of my randomness, my controlled randomness, because I have limited the amount of random values that I get, it had a maximum of 2,500 permutations, I think. So if we go, you can see there's somewhere here where I actually have the permutation code. Nope, I've deleted it. So never mind. I do have the data set. So I went ahead and I created a data set with all the different permutations. And I mean, this is not rocket science. You can say 16,000 combinations, right? What's interesting is that these two that sort of hang together in the name. So you see commissioner code and commissioner code. So the one is a direct commissioner code, and the other one's a sort of generated from somewhere else, right? And then your provider codes, you can see they're clustered together. So if you look at the amount of combinations here between these two, they come to 100, I think. Because that was my limit, right? And these two came to 50 times 10, so 500, right? Plus them together and you get 16,000, right? All of them are unique. There's no duplication, and you can see this. You can see how it steps through like you would in binary logic, in a binary logic table, right? I then have permutation ID, which is a unique ID per combination. So we should, if we go or one, last one should be 16,000. Yep, there it is. You can see what the highest value is. So 20 of that, sorry, 200 there and 100 there. Right. So you can see what the highest permutation looks like. Okay. But the bottom line is that the sequential number, it's sort of been built up, and we can use it to tag line data with a permutation. Okay. So then what happened was that I materialized my randomness. I'm going to show you what that looks like too into a solid table. So I've got my random ID, I've got my static random permutation, or static random modulus, which is based on that, and then I've got a genuine controlled random modulus, and same there and same there, right? Then in this table, what I did was I joined it back to the permutations table, and I went and I updated the permutation ID so that I know which permutation belongs where, okay? And that it becomes very, very pertinent now. And then what I did was I created, so I had two groups. I had a cluster commissioner link. So if you see these IDs, so you get one ID here of 1, and then you get an ID here of 1, 2, but they're both commissioner IDs, right? To the same effect that provider code is the same as that provider code. So they're sort of joined to the same dimension, right? But we're going to use this for security, so this is how it would work, right? So in the commissioner side, for instance, I've got a user ID, which sorry, let's start with that. The next thing I did was I created this user ID, right? So I've got the SID, the actual unique ID or GUID that has been used. I chose to deviate from the data type var binary 85, and there's a very good reason from that. Var binary 85 is only native to SQL. If you look at if you're looking at Azure Active Directory, the data type you get out is a global unique identifier, okay, represented as a string, right? So it is easy for us to control or convert that, because again, my scenario is based on the idea that we're going to use GUIDs, because that's our point of authentication will be Azure Active Directory. So at some point in time, we're going to be generating an Azure identity that we then going to be using to then provide access ranking. So I generated this typical sort of user table. Then I chose I've got a sort of a true false flag. So do you belong to the commission link table, or do you belong to the provider link table? There's a good reason for this, because it tells me when I generate my security tables, which I incidentally showed you, do I care about provider combinations or commissioner combinations, or both? And I'll illustrate this. Joining onto this, obviously, so we got a RLS user ID, and in the link table, so for commissioner, we have the RLS user ID, and then which commissioner ID I have access rights to view. Right, and the same thing happens in the provider link table. Right, here we go. My user ID, or my surrogate key for my user ID, and my link ID, or the provider ID that I'm allowed to view. Okay, then I have this view called permutated user link. So what that view does, just going to select top 1000, it gives them up the user ID and the permutation ID that I'm allowed to see. So I'm allowed to see kind of 5,000 different permutations. 2,700 different permutations, right? And if I go and I select everything, so these permutations, and I'm going to show you how this view is constructed. If we go ahead and we just go back to, let's just do this. Right, there we go. So what I've done is, let me shut off the table view because it's useless. Kill that. Let's kill that. Let's just see that. Right. So what I have done is I have selected all distinct user ID and permutation ID combinations from the user table, RLS users security table, in a join on the commissioner table where my user ID exists and where my user link is set to true, right? Then I in a joined on the permutations table, right, where the commission's ID exists in, where the commissioner link ID, which is the commissioner ID that I've got access to, joins on one or the other commissioner column. And then exactly the same for the provider column in the bottom. Okay. This then provides me the result of the user to permutation. Now, because I have that, and I then have the permutation ID here, I could literally go and say, join to that, join to this main table on the permutation where my user ID equals me. Okay. So then for row level security to work, you need to build a function. And the function is how to, is the security predicate function. Sorry, by the way, I do materialize this view out into a table called the security table here. And the reason I do that is because it's obviously it's faster. I have indexes. We've got to worry about speed because I want to be able to determine things, right? So anyway, I've got this. No, that's my store procedure. Sorry, the function. So I have a function that goes which puts a permutation ID in. So you saw the permutation ID is this, right? And then what it does, it goes and grabs. There's some security here, so because I don't want to. There's some stuff here. It gives a count back, so it returns an integer value. 1 is true, 0 is false, right? Or 1 is true and anything else is false. It looks for the permutation ID that is passed in, right? And then it selects single row. And there's a reason why you have top 1 here. It's because just in case there's something messed up in your logic, you might have multiple values returned. But anyway, so how it goes is that I give the top 1 permutation ID, right? From the permutation link table, so the materialized table here, that's based on the view, where the RLS user ID, which is that that one, because well the primary key of this RLS user table, right? Where the SID equates to the executing user's SID, right? And where the permutation ID equals the permutation ID. So those are put into place just to make this as efficient and speedy as possible. You have to, yeah. In this case, where we have 16,000 rows, we want to try to make this function as non-invasive as possible. There will be a bit of I/O overheads by doing this, but we're trying to make it as fast as possible. Right. So now that I got that out of the, this is how this function is created. So in other words, if I execute or do select out of this function, I pass. We can actually show that right now. So if we go here, I just got to find a permutation ID that's valid for me. So I'm just going to paste the function in here, and I'll give myself that. Okay, and we go select or from whatever the permutation ID. You should return a 1, right? There you go. True. If I give myself something that I know is invalid, so 16,001, I know that doesn't exist. Okay, it should return a 0 or null, nothing. There you go. Boom. See, we can test it with something that's unknown. I don't know if I'm allowed to see row 16,000. No, I'm not. And we can audit that by looking at row 16,000, as we did. So I'm just going to close this. Yeah, close that. Yeah. So when we wait, this guy. So row C, I'm only allowed to see commissioner ID 1, or sorry, we're actually on provider ID. I don't think commissioner ID. So if we look here, yeah, a row that contains provider ID 1, I'd be able to see. So here, any of these. So this guy, 15,010. So if we throw in 15,010, we should have a 1 returned. Yay, it works. Okay, great. So this is that's how this function works. It looks at the provider ID, compares it to this permutation. Right, it looks at permutation ID, compares it to the permutation user link table, which is effectively my security lookup, and then returns a 1 or nothing. But then, how this then gets implemented is that we associate that with a security policy. Right, so actually we do an alter on this. So how this policy works is as follows. I'm just going to break it up so that it's easier to read. Oh, actually, let's just move this. So the security policy has got a name, right? It's a filter predicate, right? And there's the predicate function that we created. And it's associated or applied on that table, which is our fact table that contains all the transactions, right? And that's it. We pass in the permutation ID from the table, and that's how it joins. Okay, this obviously it is enabled, and yeah, that's set up too. So this is really how simple the policy is. To create this, we would just create security policy, whatever we want to call it, filter predicate that function on that table, and that's how you say. Cool. Let's see this in action. So I want to, I want to quickly just go to the materials and select top 1000. Now this table has 1,000,000 rows in it. I am allowed to see So I think I'm only allowed to see the providers, right? So if we just go and select everything out of here, and I'm only allowed to see provider ID 1. Right, so that is 144,932 transactions, right? And all of them have a provider ID of 1 in the provider column. Okay. As we can see, I don't care about the commissioner. What we can do now is that let's change the value a bit, or let's see how we can spice this up a bit. So if we go into this and we change, hey, I must be able to see the commissioners too. Okay, now remember, I materialize the security permutation tables. I've got a store procedure that rebuilds it. Right. Let me show you how that works too, by the way. So this store procedure goes ahead and drops an index, right? And then truncates my table. I can't drop the table, I have to truncate it because it's referenced by the policy. I then go and insert into the table all distinct records from the view. I'm careful to always put in distinct because you never know. And then I have an order, so I get it like, hey, I get it sequential. It's easy to look at, and it's good because then I create a clustered index on that. Right. Now, if we go ahead and rerun this, there we go. That recreated all the rows, the 5,227 permutations. And remember that figure of I only saw 144,000 because I was only filtered here, or I was only had privy to provider ID 1. Right. Run this again, and something interesting will happen. I'll see both provider and commissioner ID 1. It will take a couple of seconds longer. There you go. And now we have 317,000 rows. And you can see here that here's a row where I don't have provider ID 1, but I have commissioner ID 1 in. And we'll see the same results. So I'm trying to find one where it's true the other way. Here, here's a provider. Right? And then we get where provider and commissioner is the same as well. So this is how you can have permutated codes, security models with permutations that cluster together, and you achieve a certain level of you create a very narrow vertical table that can effectively join on your actual data set relatively easily. One of the beauties of this, or this traditionalist way of doing it, is also that if we want to add, so let's just go in here and do it the nasty way. So I want to, for user ID 1, I also want to see provider, I don't know, for instance, right? And we go, remember this number, 317,482. So if we go and we rerun that store procedure again, sorry, sec. Boom, you can see the amount of permutations are increasing, or the amount of security roles or rules are increasing. And we go here and we execute. So 314,000, sorry, 317,000. And boom, 425,000. Wow. So now we have provider 6 that's appearing. This line is proof of that. Because commissioner. Right. Dom. Sorry, I'm going to ignore you for a second, Dom. Excuse me. Yeah. Have no. You can't see the line, right? Or all of a sudden, yeah, the provider is not provider 1, but it's, sorry, not commissioner 1, not provider 1, but provider 6. There you go. That's how easy it is to implement. Cool. I hope you enjoyed this. Cheers.